Okay, so I'm gonna start. Thank you, everyone. It's really a pleasure for me to open this session. This is the first time that this paper is presented, and I'm very happy that it is at this conference. So the work is called CLARE, which is the acronym for a causal machine learning approach to resilience estimation. And this is joint work with Talib Kilic from the World Bank and Federica Petruccelli and Pierluigi Montalbano from Sapienza University. So I'm going to start by providing you with the motivation for this work. So in the era of polycrisis, the notion of resilience is increasingly at the forefront of the development agenda. And yet, if you look at the specialized literature, it will tell you that better resilience measurement is needed because most existing indicators often lack scalability, they do not explicitly incorporate the role of shocks, or are not normatively anchored to well-being thresholds, and exhibit disappointing predictive out-of-sample accuracy. So we try to make up for some or most of these shortcomings in this project by proposing a new resilience index, which is based on a combination of causal machine learning algorithms applied to household panel data. The idea is to build an indicator that is scalable, shock-specific, so it explicitly incorporates the role of shocks, normatively anchored, and as versatile as possible. But also an indicator that aligns with the two main theoretical definitions provided in the specialized literature. The first by Constance et al. 2014, resilience as the capacity that ensures that stresses and shocks don't have long-lasting adverse development consequences. And the second by Barrett and Constance 2014, resilience as the ability to achieve and maintain an acceptable standard of well-being even in the face of a myriad of shocks and stressors. We show the potential of our methodology in an empirical application I'm going to illustrate later on, in which we use the method to build the composite indicator of climate resilience using a large cross-country household sample data. So I'm going to start with an intuition. What's the idea in a nutshell? So this indicator is essentially rooted in the impact evaluation tradition, and the idea is to estimate a data-driven resilience indicator based on estimated causal relationships between shocks, well-being outcomes, and resilience subcomponents. We use causal forests, which is a technique I'm going to illustrate later on, to non-parametrically identify the relative importance of the resilience determinants in mediating the heterogeneous impacts of a given shock on well-being. From this, we derive data-driven importance weights, which we use to aggregate the single resilience subcomponents into a composite indicator of household resilience. And then we test the out-of-sample performance of this indicator in predictive well-being both in future periods, forecasting, as well as out-of-country, cross-sectional prediction. So this is very much an applied work, as you can easily guess already, but we draw on the theoretical underpinnings and conceptual framework of the quantitative development resilience literature established by papers such as the one by Barrett and Constance 2014 I already mentioned, but also the scoping review by Barrett et al. World Development 2021, and the CSAE and Barrett 2018 JD paper in which they introduced their conditional moment-based approach. From the methodological viewpoint, we speak instead to the comparative assessment of resilience indicators that was recently conducted by Upton et al. In their JD paper in 2022. Now, our assessment of the methodology, the CLARE methodology that we propose, as well as the selection of the resilience subcomponents that go into our resilience indicator, closely follows the standards and insights set by these seminal papers, but more broadly, we also speak to other papers and approaches in the quantitative development resilience literature, including the other mainstream approaches such as RIMA and Tango, as well as newer working papers that are proposing new ways to estimate household resilience. I'm going to start talking about the methodology with a short introduction of machine learning because I want to properly contextualize our methodological contribution as well. So, as you probably all know, supervised machine learning algorithms have been specifically developed for predictive tasks, and they typically excel at predicting out of sample. And for these reasons, in economics, they have gained huge popularity in the last, I would say, 10 years or so, in order to address the so-called prediction policy problems. And our field development is no exception because they have also gained increasing traction in the development field, where they have been used often, but not exclusively, in conjunction with non-conventional data sources such as satellite data, in order to predict and map poverty, food security, and also resilience. There's a couple of papers out there using machine learning to predict resilience. So the use of machine learning is not new in resilience analysis. What is new, I will tell you in a minute. First, I want to explain that they have become so popular because they allow for, unlike most traditional econometric tools, they allow for fully flexible and non-parametric estimation of the relationship between the outcome and the set of predictors. This is the advantage. There is also a disadvantage, however, because standard supervised machine learning, as you know, essentially does not uncover any causal relationship because it can only retrieve associations, statistical associations, or correlations between the set of predictors and the outcome. And this is a problem, we argue in the paper, in resilience analysis, because in resilience analysis, causality matters quite a lot, because you should be primarily interested in estimating, first, the impact of shocks on well-being, and second, the protective role played by resilience components in this relationship. That is, how the resilience determinants intervene in the causal relationship between the shock and the outcome and drive heterogeneous effects, how they mediate the relationship between the shock and the outcome. These are causal questions. And for this reason, we don't rely on standard machine learning, but on newer causal machine learning techniques, which have been recently developed in order to estimate heterogeneous causal effects, rather than merely to predict outcomes out of sample. Once we estimate these causal relationships, we then exploit them in order to build our data-driven resilience indicator. So the technique we use is called causal forests, developed by Ate and team in a series of papers that is already hugely popular and is an adaptation of random forests, one of the most popular and well-known supervised machine learning routines developed by Breiman in 2001. Causal forests have been specifically developed for the estimation of the so-called conditional average treatment effects, which is a very popular building block of treatment effects in causal inference econometrics. Right now, essentially, they constitute non-parametric and very granular estimates of treatment effect modifiers based on a set of chosen covariates that in a famous paper, Ate and Imbens labeled the treatment effect modifiers. Now, pragmatically, operationally, in our setting, the outcome is a binary well-being variable W based on some kind of normative threshold. So, to be clear, food insecurity, poverty, etc. The treatment is a shock of interest S, which can be a climate shock, a conflict shock, or any other type of covariate shock. Is going to be a climate shock in the application I show you later on. And the shock effect modifiers are indeed the resilience subcomponents R. A set of resilience subcomponents R, all of them measured from before the shock, because we don't want these variables to be themselves affected by the shock. So the main assumption of the causal forest is called the conditional unconfoundedness, and in order to make it credible in our setting, we follow the recommended double orthogonalization approach, which essentially exploits the Frisch-Waff-Lowell theorem in order to non-parametrically control for confounding factors. In practice, we start by separately orthogonalizing both the outcome and shock variables with respect to many different potential confounders by running two preliminary and fully non-parametric regression forests. More specifically, the model we estimate is this. So on the left-hand side, you see the well-being outcome W for household I in wave T. And on the right-hand side, you see a partially linear model, which is very popular right now in causal machine learning because it allows you to strike a balance between complexity and interpretability. Why? Because the treatment effect, tau, which you can see here, is assumed to be additive with respect to the outcome levels, so it's easily interpretable, and it's heterogeneous. As you can see in the parentheses, it depends on the pre-shock values of the resilience components. But the data generating process for the outcome variable, which you see in function f, can exhibit almost arbitrary degree of complexity. We do not assume any functional form. We don't make any functional form restrictions regarding the form of this data generating process. So in step one, we estimate W star and S star by regressing both the well-being outcome and the shock variables on the confounders, which you can see in function f. These include variables capturing household and country level time invariant unobserved heterogeneity, which sounds like a mouthful, but essentially is what in a parametric setting you simply call fixed effects. We adopt a Mundlach type approach to include fixed effects in these settings, non-parametric time trends, and other lagged time-varying household characteristics. Once we have debiased and the noise, both are outcome and shock variables, we regress the residualized outcome on the residualized shock, conditioning on the shock effect modifiers, on the resilience subcomponents. In this way, we are able to estimate household-specific shock effects, so very granular effects, and then explore the heterogeneity based on the values of the resilience components. At the end of this process, we are able to retrieve a variable importance ranking for the resilience subcomponents. This is telling us the relative importance, the relative protective role played by each resilience subcomponent in mediating the relationship between the shock and the outcome. This allows us to establish an objective hierarchy, a data-driven hierarchy among the resilience subcomponents, which we use to compute CLARE. So what do? We take the variable importance measures, we normalize the relative important weights so that they sum up to 1, and then CLARE is simply, essentially, a weighted average using the data-driven weights estimated in this way of the standardized resilience components. And this is the first term that you can see here. This is the weighted average using the data-driven weights of the resilience subcomponents from the previous wave. Then we rescale this weighted average by the term that you can see on the right that looks complex, but actually simply the probability of being above the normative threshold, even under the shock scenario, which is also estimated by the causal forest, and multiply the resulting quantity by 100. This resulting quantity is our indicator of resilience, a composite indicator of resilience, CLARE, that ranges from 0 to 100 for interpretability. Once we have built this indicator, this is a continuous indicator, but then you can binarize it using various criteria or thresholds for the cutoff so that you can obtain a dummy for non-resilient versus resilient. Later in the application is going to be the median for simplicity. So why these two terms here? Because the first, the weighted average, is capturing the drop in well-being that is due to the shock as mediated by the resilience components, and this on the right is capturing the relationship between the shock and the overall probability well-being levels. This is because Afton et al. 2022 tell you in their paper that a good resilience indicator should be correlated both with the change as well as with the level of well-being. So I want to tell you, before talking about testing and then move it to the application, that all of this procedure, model estimation and estimation of the data-driven weights, is computed exclusively on training set data. Okay? Once we have done this on a training set, we then export the weights to other held-out data. We plug in the new values of the resilience of components from those held-out observations, and in this way we are able to compute CLARE, take the weighted average, and compute CLARE also for the testing set. And this allows us to test the performance of the indicator exclusively on the testing set data on which the model was not estimated. So there is a clear division between the design stage, the training stage in which we train the model and estimate the weights, and the testing set in which we estimate the performance of our indicator. Testing set, what kind of testing set exercises we are interested in? A regression task and a classification task. A regression task, we want to check how the continuous CLARE indicator predicts the continuous well-being indicator out of sample. Classification task, we want to check how a binary version of our indicator is able to predict a binary well-being indicator out of sample. As I said, purely for illustrative choices, in this case, we employ the median. So we define as non-resilient households whose CLARE score is below the median, and resilient, all the others for which it is above the median. But this is an arbitrary choice, okay? We don't have yet, we are thinking a lot about how to make even this last step, discretization of the continuous indicator, data-driven, is still an open question. One can use various criteria. This also depends on cost-effectiveness criteria, whether or not you are interested in minimizing false negatives versus false positives, if you are in a budget-constrained scenario, and so on and so forth. And now what matters is not really the performance of our indicator in absolute terms, but how do we fare compared to what's already existing out there. So we benchmark the performance of our indicator against the CSAE Barrett 2018 resilience score based on the conditional moment-based approach, because this was the best performing resilience indicator according to the comparative systematic assessment by Upton et al. 2022. And then we also check performance with respect to other simpler approaches, such as a naive approach, in which you simply use lagged well-being in order to forecast future well-being, as well as the realized resilience approach, which is the way in which other methodologies, such as RIMA and Tango, build their binary resilience indicator. Now it's time to talk about the application. I'm going to show you preliminary results. So household data come from the very well-known LSMS ISA collection. 4 sub-Saharan African countries in our sample: Malawi, Nigeria, Tanzania, and Uganda. The time span is 2008-2020. The sample is large, more than 30,000 observations and 18 survey waves. And then we build an outcome variable W, which is a dummy for food insecurity, taking value 1 if the food consumption score was equal to or lower than 35 and 0 otherwise. Why this outcome? Why this cutoff? Same of the one used by Upton et al. 2022. Then we also followed this paper for the selection of resilience subcomponents. So which resilience determinants we include in the construction of CLARE? All the variables from the study by Upton et al. 2022, which was possible to replicate and harmonize also for this alternative dataset, ending up with a total of 19 variables. Whether data come from the global SPI database based on the Krugrid data from the University of East Anglia. This is a medium range resolution. So for robustness, we are also doing now, we are also computing now new SPI values based on the CHIRPS time series data that have a much higher level of spatial resolution. Another measure of shock S, we are interested in the construction of a climate resilience indicator. So the shock S is droughts, which we define as a binary variable that takes value 1 if the average growing season value of the SPI across all the growing season months in between 2 waves is below the 25th percentile of the distribution and 0 otherwise. To define growing season months, we rely on crop calendars on FuseNet US needs. Estimation details, and then I move to the results. So for forecasting, we train the model and estimate the weights only on the earlier 1 to 3 waves for all countries, and then we predict and test the out-of-sample performance only on the later waves 4 to 7 of all countries. For out-of-country prediction, estimation is slightly more complicated because it is iterative. So we iteratively train the model on a rotating 3-country dataset, predict on the held-out country, and then test the out-of-sample performance on the pooled dataset of all 4 held-out countries. Now I'm going to show you the results. I'm going to start with forecasting and then move quickly to out-of-country prediction. The first thing I want to show you for the forecasting exercise is the heterogeneous effects of the shock that we estimate with the causal forest, and these are the household specific effects. So on the x-axis you see the estimated shock effects at a household level expressed in percentage points. On the y-axis you see the frequency, and the vertical red dotted line is the average treatment effect, which we estimate to be close to 5 percentage points and statistically significant. So this is telling us essentially that if there is a drought, this will increase the probability of a household becoming food insecure on average by about 5 percentage points. To contextualize, the unconditional probability of being food insecure is approximately 16%. Okay? This is the average effect, but then as you can see, the forest detects quite a lot of heterogeneity in the estimated shock effects. So the most important question is, what are the resilience subcomponents that are most important, that are driving most of the detected heterogeneity? And this is the question that is answered in this table. So this is a summary of the variable importance weights that we estimate with the causal forest. On the left column, you see all the 19 resilience components. I remind you that all of these are lagged, so they come from the previous wave. Okay, we are using components from 3 to 4 years ago, depending on when the previous survey was collected. On the right, you see their importance weight, which for interpretability we have reported in percentage term, in percentages. So looking at the components, the first 3 or 4 components are the lag of the well-being indicator, household asset index, distance from the market, and tropical livestock units. Jointly taken, this accounts for more than 60% of the detected heterogeneity. So all the other components account for less than 40%, the first 4 for most of the heterogeneity. And they are roughly consistent with the literature. Now, for instance, the importance of assets in the poverty traps literature. Now, a very important point is, can we use this objective hierarchy of resilience subcomponents to prioritize data collection efforts in the field, which is something you might want to be interested in if you are in a budget constrained scenario, or if it is a problematic data scarce environments. You can, provided that the estimated hierarchy among the subcomponents is not particularly sensitive to substantial changes in the training set. What happens if I substantially alter the training set? Will the weights remain stable or not? Let me show you the corresponding importance weights for the out-of-country exercise. This is the related table. So this comes from a training data set of 3 countries, not 4, and all waves. Whereas for the forecasting exercise was all countries, only the first 3 waves. This is to say that it is a substantially different training set. And yet, if you look at the objective hierarchy that we estimate, the top 3 resilience components as well as the bottom 3 resilience components are exactly the same as in the forecasting exercise. So yeah, there is stability in the estimated weights, which is good if you want to use it for targeting purposes or data collection prioritization. Now, let me show you the results of the forecasting performance. Here you see up the metrics for the regression problem and below the confusion metrics for the classification problem. I'm going to start with the regression metrics. Most of them are those employed by Upton et al. 2022. So Pearson correlation coefficient and the Spearman rank correlation coefficient are above 0.5. We also, which is larger than what was estimated in that study, of course, using another sample. We also repeat the exercise, that is, we regress the continuous well-being indicator on our CLARE indicator from the previous wave, and then get the normalized root mean square error, which is 0.32. I'm going to compare it with the one we get using the CSAE Barrett methodology in a minute. And here you can see the confusion matrix. So what we can see is that we achieve a sensitivity, the ability to identify true positives. That is the ability to correctly anticipate households that are going to be food insecure in the future wave. It is almost 82%. So CLARE is able to anticipate more than 10 out of 10 households that are going to be food insecure in the future wave. And that specificity and overall accuracy, however, are much lower. Overall accuracy is 61%, but this is by design. Because I told you that we use the median here for an illustrative choice to define no resilient versus resilient. So half of the sample will be no resilient, but I told you that the unconditional probability of being food insecure is only 16%. So by design, we are going to get a lot of false positives. As I told you, how to binarize this continuous indicator is still an open question for us. Let me show you the corresponding results of the CSAE Barrett method. We repeat the same exercise for forecasting, regression metrics, and analogous classification, confusion metrics. So we see that for the continuous indicator, there is a large gap, which is in favor of CLARE because the correlation coefficients are quite lower for the CSAE Barrett indicator, and also the normalized root mean square error is about 10% lower for CLARE. For the classification metrics, we also outperform the CSAE Barrett indicator across specificity, sensitivity, and overall accuracy, but the gap is smaller. The margin is narrower. Now, I also told you that we do a lot of other comparisons. I don't show them, but I have in the additional material if you want. There is really no comparison because we actually outperform the other approaches by a much wider margin. I want to show you one last thing before moving to the out-of-country results and then wrap up. What happens if suppose I want to prioritize data collection efforts. I want to collect data only on the top 3 most important components. Can I use the objective hierarchy that we established with the construction of our CLARE indicator? You can, if the forecasting performance doesn't change very much, if you repeat the entire process using only those top 3 components. And so this is what I want to show you here. The corresponding forecasting performance if we repeat the same process by discarding all the unimportant components and using only the top 3 components. As you can see, the performance metrics are barely affected. There is a very slight deterioration in performance, which means that, yes, in principle, you can discard all the unimportant components out of the stable weights that we estimate, focus on the top important ones, you will still be able to get a very, very similar forecasting performance. If we repeat the same for CSAE Barrett, the drop is larger. Now let me move you quickly to the out-of-country results. We were expecting worse results for out-of-country because in principle we thought that it was more difficult to predict the well-being status on observations from entirely different countries than the one on which the model was developed, compared to forecast the well-being outcomes for the same households over time. Instead, the performance metrics are higher than the ones we get for the forecasting exercise for both regression and classification. The correlation coefficients between CLARE and the food security indicator and the food consumption score is now close to 0.6, and for the classification exercise we get a sensitivity of almost 83%. What are the corresponding results for CSAE Barrett methodology? Actually, the gap is now larger than for the forecasting exercise in favor of CLARE for both the regression problem as well as for the classification problem. Now let me move to the wrap-up. So essentially, we use a data-driven weighting scheme, which is based on the estimated causal relationships between shocks, outcomes, and resilience components. And in this way, we are able to credibly address the issue of how to aggregate the single resilience subcomponents into a composite indicator of resilience. How to aggregate the components of a composite indicator has always been a thorny issue in development. Just think of the Human Development Index, of course, and we try to propose a data-driven way to do this for our resilience indicator. Now, an important feature of CLARE is the scalability, because essentially once you have established the objective hierarchy among the resilience subcomponents, you can use it to prioritize the most important targetable characteristics, which might be particularly important when you are in a budget-constrained scenario or there are cost-effectiveness criteria in the data collection process. All of this revolves around the central role of shocks. So I think this is one of the main novel aspects of CLARE compared to the existing indicators that do not explicitly incorporate the role of shocks. CLARE entirely revolves around the impact of shocks. So this is really a shock-focused modeling framework for resilience. Okay, good, but it comes at a cost. The cost is that CLARE must be separately estimated for any different type of shock affecting well-being that you might be interested in. This is the cost, the price to pay, but it makes sense if you agree with me that intuitively makes sense that not only the weighting scheme of the resilience subcomponents, but also perhaps the selection of the subcomponents themselves that goes into the indicator depends on the specific type of shocks that is affecting well-being. All of this, in principle, makes it possible to operationalize CLARE for a variety of purposes that you see listed here. But before we can even think about operationalization of this indicator, there is still so much we have to do. I showed you a lot, but I can tell you that much more is in the pot. I would like to tell you about it, but I think I'm going to stop here because I already talked too much. And that's all I had to say. Thanks a lot for your attention.
I think, as you can already tell, it's not an easy paper to to be the one commenting on, but thanks. I mean, it's a job well done. I'll give a few comments quickly. Let's start with the objective and contribution. I think there are a few of the slides I had that I'll skip, interest of time. But the paper introduces the CLARE, a new resilience index, built using causal machine learning, specifically causal forest, to assess household resilience in a shock-specific way. It aims to overcome limitations of existing resilience measures that are not shock-specific. They lack scalability and perform poorly in out-of-sample predictions, and I think that came out very clearly from his presentation. And when I looked through the paper, I think the main advantages, as claimed by the authors, over the existing measurement approaches, that it's shock-specific. I think the ones that we have at the moment, it's just measure households' capacity or individuals' capacity to either bounce back to the original status or even better after a shock, but the shock is not quite defined. But this one goes direct to identify specific shocks. Of course, use of machine learning approaches. I think this is the first one I've seen in the field. Maybe there could be others, but I think this is the one that has outrightly used machine learning to estimate resilience. And then the computation of composite resilience index. This is from multiple household capacities. That's my understanding of the index that you're computing. But on one well-being indicator and on one shock. And I think I'll say a little bit more about that in a few minutes. but also the use of weights. It's linked to what I've just said, but the use of weights to emphasize subcomponents that more strongly mediate the shocks impact on well-being in the final resilience index. In my thinking, it's a great paper, but again, highly technical. It's rigorous, but also highly technical. Maybe not immediately available for everybody, but I think if you're really interested and take your time, it's a very interesting, and especially if you're interested in the field of resilience measurement, I think it's an interesting paper to go through. So allow me to skip all this. He spent some good time giving a start, and then I'll go straight to the points, the things I think maybe you might want to think about. And the first one is, how objective is the choice of your outcome variable, the food consumption score, besides being used in a comparative paper, the study by Upton in 2022, which is heavily cited in your paper. And for a few reasons, I think FCS, as you said, and as we know, measures the dietary diversity, but not food security per se. And we know in the presence of shocks, I think for me, food security, it's more important to a household than dietary diversity. That's my thinking. And as access to food in the presence of shocks may be a better outcome, maybe for you. And coping mechanism, it's commonly used for that. Maybe there could be a few others. It's not to invalidate what you've done, but maybe asking for much more, because I think LSMS data, you have access to many more other outcomes that you can use. And you actually in the paper do mention that, like the indicators and all that. So rather than restrict yourself to one of the indicators that is available, could you try do a little bit more with the data that is available? And I think I've mentioned that. Could you try? And as you said, of course, FCS and even food security indicators, they are quite hard sometimes to predict. So maybe you can try other outcome variables. So then the second one is lack of current resilience measurement approaches. CLARE considers one well-being outcome, that is FCS, at a time. So, when the first impression I got, talking of composite index and all that. So I was really hoping, and I think I'm a little bit familiar with the literature in this field because of the paper that I'll just be presenting after this. So I was quite excited, finally, something that gives us a composite index, is finally here. But it's looking at, one outcome, a well-being outcome at a time. But we know that shocks affect, or shocks, or even just one shock, affect multiple household or individuals' well-being indicators simultaneously. And so maybe if it would be possible to then integrate or use CLARE with multidimensional poverty measures, and see whether we are able to know, overall how are households able to be resilient generally or overall. And I think that also related to that, the paper claims to be shock specific while computing an aggregate climate resilience indicator, but clearly computes food security resilience, that is a single outcome, against drought, that is a single shock. I think we need some clarity there. And the current measures, they compute generic resilience to multiple shocks. I think that's maybe one of the, again, the strength on the other side of the current ones. Because here you don't identify, the current one, you don't identify a single shock. I think for you identify a single shock. But maybe I was thinking, if there is a way using your approach, you could compute resilience to different shocks, then aggregate this to an index. That would be quite a huge contribution, I think, to the literature on measurement of resilience at the moment. And then you convert a continuous outcome to a binary choice. and such that, FCS, if it's below or equal to 35, those are considered as food insecure, and above that, they are considered as food secure. But did you check for robustness of your results to this subjective choice? I think you already mentioned that you're looking into ways of being data-driven in the selection of your threshold. But maybe one of the things that you could immediately do is to just check for sensitivity of this subjective choice in your analysis. And then also, I think besides using machine learning techniques, it would be also interesting to see or to know how different your approaches are different. They are from CSAE and Barrett's work, but of course also Barrett and Costa's work, which again you have recite in the paper. And I think out of the many other approaches that you compare, this is the one that is closest to your work. It would be interesting maybe to discuss that. It also might be useful to check the work. I don't think they've published this yet, but I think it's available as a discussion paper, the work from Will Masters and the team. Thank you.
Time for questions? Okay, thanks a lot. I think this was really a great discussion of our preliminary work. I'd like to quickly reply to your points, and then maybe we can talk in further detail after the session. So the first point regarding other proxies for the food insecurity. So now we use the food consumption score. Of course, we could use also other measures. We didn't do it yet. As I said, now we are trying to establish this from the methodological viewpoint, and in this way, we are really our benchmark is the seminal papers that I mentioned before. So we are closely following what was done in those previous papers, but in principle, it's certainly doable, and I think we should do it to demonstrate also, let's say, robustness to different proxies of a given well-being phenomenon. So the point about other well-being variables other than food insecurity, so think, for instance, of assets in the original 2018 paper by CSAE and Barrett, I think they used tropical livestock units as a measure of assets for the outcome. This is doable. This is actually something that we are planning to do. So to also extend and check robustness with respect to other outcomes. I think this comment also, and also our approach intertwines in a particular interesting way with a recent working paper by Lee et al. That propose an approach which is also based on different weighting schemes, but on the left-hand side, on the outcome side, to integrate, to generate a measure of multidimensional development resilience using different well-being outcomes combined among them. So this is certainly something that we are planning to further explore. Then regarding the sensitivity analysis for the food for the definition of food insecurity, so in the benchmark we use the 35 cutoff that was also used by Upton et al. 2022. We also tried with the median, so defining as food insecurity was below the median, above the median, and the results are robust. Of course, we can also try with yet alternative definitions, but this sensitivity analysis at least is reassuring. Then different shock indicators. Yes, a good point. In principle, it would be great to also aggregate all the different shocks into a single general shock measure. I don't know how sound such an approach would be, because you would be integrating climate shocks and conflict shocks. As I said, my view is more that an indicator resilience is not resilience like a general purpose concept, but is resilient to what? And so the type of shock is important. I think that this indicator should be shock specific and not a general purpose resilience indicator, which is the main difference and also the main contribution with respect to the other existing resilience indicators. As I said, don't explicitly incorporate the role of shocks. I will think more about it anyway, because it's an interesting comment. And then what else is different other than the use of machine learning compared to CSAE and Barrett and other papers? As I said, from the point of view of the theoretical underpinnings and the conceptual framework, we draw quite heavily, it is clear, from the conceptual framework and the causal framework established by these papers. But then if you look at how they do estimation, I think that there are a number of key differences, because the way in which then the framework is clearly causal, but the way in which then estimate resilience, I think, is more on the correlational / predictive side, in that they don't explicitly estimate causal relationships between shocks, resilience subcomponents, and how they mediate the impact of shocks on the outcomes. I think this is the main novelty that we get with causal machine learning. And then there are also other differences in their theoretical underpinnings. They emphasize that in line with the poverty traps literature, that there are very strong nonlinear dynamics, welfare dynamics, but then in the estimation, they mostly use parametric models and functional form restrictions, and at most they incorporate polynomials of the outcome in order to try and capture those nonlinearities. With this approach, we can fully and flexibly capture nonlinearities and interactions. And last thing, the working paper that you mentioned, I'm not aware of that. I'm certainly going to take a very close look at it. Thank you. Questions?
Thank you very much. Sorry, I came late, so if I ask a question you covered before I came, apologies. So one is on the inclusion of the lagged food consumption score.
Yep.
I'm not sure how resilience is fully defined, but if it's the classical way of defining resilience, maybe the one way of defining it in economics, that your utility shouldn't change so much because of shocks or perturbations, then I imagine that your previous food consumption score is inherently part of the definition of resilience. If there's a shock, I shouldn't move too much away from a previous, food consumption score. And also, that relates to how much power it had in terms of importance in the variable importance when you're ranking the variables. And I'm curious, if you just used it alone, how much of that sensitivity would reduce from 82 or 81 without the other two? Because I know when you use the 3, it almost remained the same.
Yeah, one quick question is, when we're looking at using resilience for impact evaluation, one of the issues with more capacities-based resilience indicators is that it's very difficult to move those. And I see that as a big advantage of the approach that you're presenting, but also of the CSAE and Barrett approach, that this can be actually shifted by an intervention. So I think when you're talking about resilience with, resilience to what? Probably we want to focus on those shocks that an intervention is improving resilience for. So if you have an intervention that helps cope with drought shocks, then indeed it makes sense to base it on the resilience measurement on the drought shocks rather than a composite shock measure. So maybe in your motivation, that's something to factor in. And then I wanted to push back a little bit on the point that the food consumption score isn't good at getting at food security, because malnutrition is a massive aspect of food security and people need their micronutrients. And if women get affected by shocks, they're often the first ones to cut down on their meat consumption. They might still get the carbs, but they're not getting the micronutrients, the protein anymore. And that's a big issue when we're thinking of food security. There's more to life than maize. So I wanted to push back on that point.
Thanks. I think the paper is really good. I think the methods look very robust. I really like it. I think for me, the only thing that you probably need to motivate more is like the selection of the countries, because then you work with 4 countries in sub-Saharan Africa. I could see some countries that are quite massively different from the other side. So of course, then the question would be, is it data constraints that sort of like forces you to work with just these 4 countries? And how would you, for example, would you think that the model would work in, say, I don't know, Burkina Faso or Namibia, or countries that are more like, have more drought than others, countries that are more Muslim than others and all that?
So this is related to that question, actually. So if FuseNet were to shut down, how would you source a replacement for that?
Okay, Can I? Well, thanks everyone. All really great comments. I'm going to start in the order that I received the questions. So regarding the question on the lag of the food consumption score, again, we included it because in the most important methodological papers out there, it's included in the estimation of the resilience indicator. What happens when we, what is the predicted score of this lag alone? This was basically your question. I think it's a very important one. That's why we show, I didn't show it in the main presentation. I have the result in the additional material. Essentially, we show what is the performance gain over a very simple, naive approach in which you simply use the lagged food consumption score in order to forecast future food consumption score, and the gap is wide. One of the main findings in the paper by Upton et al. 2022 is that those three mainstream indicators, RIMA, Tango, and CSAE and Barrett, with CSAE and Barrett being the best, but also CSAE and Barrett did not generate significant improvements with respect to simply using the lag of the well-being indicator to forecast future one. Here's the gap is wide for the continuous indicator. We have quite a large gap in favor of our CLARE indicator, but again, for the CSAE and Barrett indicator, the difference with this naive approach is more. So yes, there is a lot of more predictive power that we get by using our methodology rather than simply the lag of the outcome. Then coming to the second point, this is really a great suggestion and a great point. Absolutely, I agree with you, and we still have to think a bit about it. How to use it? In principle, you can use it. Yes, just like CSAE and Barrett, I think for the CSAE and Barrett indicator is one of the main advantages over the existing resilience approaches, that you can use it for policy targeting, but also for policy evaluation. You can also do the same for CLARE, because clearly, as you say, you capture the shift, so you can also capture the shift of a policy change, of how these intermediates with a shock, such as a drought, but also another shock, and it's really something very important to do and think about in the future. Thank you. On the third point, I think it was the selection of the sample. You got it. So data constraints, essentially we need longitudinal multi-topic data, because resilience is multidimensional, so you need the multi-purpose data and longitudinal ones if you want to do forecasting, but also for out-of-country prediction. So we look at the best collection that is longitudinal and multipurpose, which is the LSMS ISA. This collection is made of only 8 countries, and the 4 that we selected are the ones with the most waves, essentially most survey waves. Because Burkina Faso that you mentioned, I think it's only 1 wave. Philip, if I'm not correct, 2 waves, okay, but that is not enough to do what we want to do, because we divide between training and testing, so different waves go in training and different waves go in testing. This is not possible with 2 waves and using only the lag, the covariance. And finally, the last point is about sorry, I forget it. Yes, how? Okay, no, I didn't say it because it's clearly a problem, but I think we can rely on the FAO crop calendar. We hope that this won't be the case, of course, like everyone in the room. But in case that happens, I guess we are going to rely on the FAO crop calendars or some other source. But for sure, we need a source, because what we want to capture in the case of climate resilience and the impact of droughts is the conditions during the agricultural season, during the growing season. So we clearly need the crop calendars to identify growing season.
All right, and I think now we move to use of resilience index in evaluating policy interventions. This is work done with colleagues from IFPRI and one from University of Greenwich in UK. And as a way of introduction and motivation, so I think agricultural credit promotes households' productivity and well-being through investment in modern technologies and higher yielding inputs. And I think there's a lot of literature that now links access to credit with better or enhanced investments amongst smallholders, but also linking access to credit to technology adoption, and also household productivity. But there's not much literature that goes beyond adoption of technologies and all that, and even productivity in terms of yields and direct production from the farms to well-being. There's a little bit of it, but not much. But again, the gap in literature that links access to credit to higher order outcomes like resilience that we just talked about, that the gap there is even more pronounced. And this could be, I think, it's interesting, this presentation coming after his, this could be associated to lack of, measurement approaches, good measurement approaches of resilience. And we do adopt, I think CSAE and Barrett, they are more present in this room than those of us who are physically here. So we adopt the CSAE and Barrett, of course, first work coming from Barrett and Constance, and then CSAE and Barrett is more an application study. So, but we adopt their approaches into measuring resilience to food security. Interesting presentation after his. And we use CSI, that is the Coping Strategy Index, which measures the number and the frequency of coping strategies that households use when they are faced with food insecurity. So, and that's our well-being indicator for the study. And we simply compute the insecurity index or the food insecurity index by summing the number of coping strategies employed by specific households. And this comes from 3 rounds of data that we collected during an RCT that we're implementing. So we have a baseline, midline, and endline. The food, and as you can imagine, and also from the graph that we can see, I think when you sum them up, the higher the indicator, that means the worse off the households. 1 to 8, and 1 would mean that they are using very few coping strategies, and 8 would mean they are using many coping strategies. But for the sake of the analysis here and the interpretation, we reverse that such that an 8 means the house is really food secure, and a 1 means that a household is really food insecure, to make the rest of the interpretation easier. So I think I'll not spend much time here because we're just from discussing this, but following the CSAE and Barrett work, of course, Barrett and Constance first. So we adopt the development resilience measurement approach. And here they define capacity, resilience as a capacity over time of a household or an individual to avoid falling into poverty in the face of various stressors in the wake of immediate shocks. Here it doesn't consider, it's not shock specific. Here it's a myriad of shocks that would maybe hit a household. Then their capacity to remain above the poverty line, that then can be defined as resilience. And they can actually be called resilient if this capacity remains high over time, and then the household can be defined as resilient. So resilience can be presented then as a conditional moment function for well-being, and the well-being indicator here is food security, which is pretty much more access. Such that, so that the equation that I include there, so that tells us that M is the kth moment of a household, and this could be the first order moment, that is the mean, the second being the variance, and I'll mention those two because those are the ones we proceed with for this paper, and depends on the distribution that you assume for your well-being indicator, and I'll mention the reason why we go with those two. So, and here then is to say that we assume that the current well-being indicator or food security for this case, it's then a function of their well-being in the previous seasons, and of course also other household characteristics, but also other maybe farm and regional characteristics. So for this work, we assume that our well-being indicator, food security, is gamma distributed, and then with the first and the second moments, that's mean and variance, then you're able to then fit your resilience indicator. So and for the first moment, the conditional mean, we estimate using this equation down there, and then the second, of course, we do this, and then we fit we fit this equation, and then store the mean. And then for the second moment, conditional variance, then we use this indicator, the equation down there, and again we store the residues from the mean, and then we square them. And the assumption here then is that the residue is the standard deviation, and when you square them, you get the variance. And then we use the gamma distribution to estimate resilience. So then moving on to how we then measure and define households as either resilient or non-resilient. So resilience here is hence defined as the probability of a household achieving a normative well-being. We call it W bar, food security in this case. And this is a fractional outcome. Since we're talking about 0 to 1, the probability of the household hitting one of the, it's a subjective choice again. So the resilience here is the probability of the household achieving that normative well-being or being above that. So, and we set the normative level for us at 5, that is out of 8. So we set it as 5, and as I said, it's a subjective choice. But for our results, and I think I'll show that, we also do sensitivity analysis to show whether our results or our findings are robust to that subjective choice. So this tells us that resilience is quite low amongst the households that we are working with. So, and the graph here shows the distribution of our households at varying levels of threshold. So, as I said, we already selected 5, but this is just to show how badly the households are doing. So, resilience decreases, of course, as the minimum threshold rises. So, when you start with 1, you can see most of the households can be defined as resilient if you set the minimum threshold to be 1, and that would say maybe they are using only one coping mechanism. But as you keep increasing or rising the threshold, the households keep moving to the left, showing how low the probability of them achieving that threshold is. And by the time you hit the minimum threshold of 4, almost all the households lie below the 50% chances or 0.5 probability of reaching that normative food security level. So, and then we go ahead. So actually we selected 5 as our threshold, and that gives us already one of our outcomes, which is a fractional outcome. So, but we go ahead and compute a binary outcome that defines households either resilient or not resilient, based again on another subjective choice. So the same questions I was asking, I expect them to be asked here. So again, we define if the household's chances or likelihood of achieving level 5, that's the threshold that we set, is below 35%, then we define that household as irresilient. And if it's above that, it's equal to that and above, then we define that household as resilient. And so we proceed with our analysis using those two outcomes, a fractional outcome and a binary outcome. So to the policy evaluation, so the RCT that we set up here was to assess the role of agricultural credit in enhancing household resilience. And then we compare two types of credit here. We have insurance embedded credit. That was credit that was insured against droughts. It's called RCC, or risk contingent credit. And then we have traditional credit that didn't have any insurance bundled to it. And the study is conducted in Kenya between 2017 and 2018. And 2017 was baseline. And then the same year, we did the first round of intervention. And I think in 2018, around June, we did the midline survey. And then there was an intervention again in 2019, and then endline data collected in 2022. The study actually continues. I'm informed, I left the team, but I'm informed even last year there was some intervention and data collection that being done. But this study is based on the first and the second round of intervention. So we had two main groups, and that is a control group and treatment group. And then the treatment group, then it's broken down into the households who are offered risk contingent credit, that is insurance embedded credit, and the other group was offered traditional credit. So the estimation that we ran, maybe quickly to mention here, we first treat our data as observational data and estimate the first two regressions. The first one is on the fractional outcome, and the second one is on the binary outcome. But again, here we use matching methods. We treat the data as observational, but we use matching approaches here, particularly entropy balancing to account for causality that may be there. And then we go ahead and again now look at our data again as experimental data, then estimate equations 3 and 4, and the equation 3 estimates the intent to treat, and that is applied to both the fractional and the binary outcome, where we treat the fractional outcome as a continuous variable. And then the last equation, then that is giving us the local average treatment effects on both of those outcomes. Just to mention that we have balanced we did balance checks, and our randomization was effective. And then we go to the results. Both credit types, that's the risk contingent credit and traditional credit, had a positive effect on our main outcomes, as you can see, and that increasing their households' resilience. Remember, I said we reversed the food insecurity measure to measure real security, food security, and that means positive coefficients favorable in this case. So as you can see there, both ITT and LATE tells us that the both types of credit increased their resilience. And if you look at the binary outcome, that is panel B, we see the same results. And of course, when you look at, we are estimating with and without household covariates. So without covariates, it's still positive, not significant. But with covariates for the binary outcome, it's marginally significant. That is for RCC, but for traditional credit, I think it's the effects there are even stronger. And again, when you look at the estimation where we treated our data as observational, but again we used matching methods. And this pretty much for robustness check, and then we get similar results. I think across the two outcomes, that's fractional and binary, we see intervention, that is both RCC and traditional credit, enhance their resilience. And again, the sensitivity test that I was talking about, and here we are looking at, now that the results that I just presented are based on a subjective choice, where we look at the threshold as them or the household at least attaining a 5 out of 8 in terms of their food security. So here I then ran the analysis based on all the other levels from 1 to 8. If you look at the results, and this table shows the regression that has controls or household covariates. So we can see the results are pretty similar, apart from when we expect them to be, strongly and fully resilient. That is W bar 8. That one, it's not significant, but all the others, they are positive and significant. And that is for ITT, and the same thing for LET. That is local average treatment effects. It's the same thing. Of course, it's expected, it's a scale change. And the same thing when we look at the observational approaches with entropy balancing. Again, they are all significant, apart from the highest level of food security or resilience to being food security resilient. And apart from RCC, I mean, those who are assigned or taking RCC, that's not significant for the highest level of food security, but still traditional credit, it's still significant. So the conclusion and the recommendations. So agricultural credit should be considered as a viable tool for building resilience for rural communities. Then the enhancement of credit access to rural communities as a remedy to in the face of major shocks should be considered. And this the reason I say this, when we compare the effect between RCC and TC, we don't find, the difference is not significant. And that means then access to credit. If we're able to enhance access to credit, and some of our earlier work, and I think there's mixed finding when it comes to these, but some of our earlier work shows that the uptake of insured credit was higher than the non-insured credit, and so enhancing credit access has a potential of improving households' resilience to shocks. But again, further research on computing composite resilience indices that is required. It's interesting to see your work. I think it's one of the major contributions towards that direction. But again, also, as I gave you some comments, I think there's much more to be done to give indices that they are more inclusive in terms of multiple shocks, but also in terms of multiple household well-being outcomes. And that, thank you.
Thanks, Mike, for the great presentation. I'll be sharing my comments. Great. You had a wonderful presentation, and the implications it has for Africa and every single person in the banking industry is great. But then this implication also goes all the way to the actual farmers and the households that use that credit. So we like this contribution, and the fact that we need to focus more on risk contingent credit is becoming more pronounced across most of the East African countries. So thank you for that. The paper has a very robust empirical approach. They have a clear way they set up their RCT designs, and the randomization is also great, and also the index. I mean, you stated that it was one of the first that is continuous in tracking the effects. Now, in the interest of time, I'm going to rush through all the comments. So, one surprising result I found, you indicated later that maybe there was some slight differentiability, was the issue on why RCCs are non-differentiable to the TC. Now, it's I'll just give a small experience from Uganda. We have interventions that we give that are very similar to this. And the issue that arises of why you cannot differentiate the two is once the household goes to get the loan, the bank has an interest in itself not to give you the risk-insured loan. They'd rather give you a loan that is more expensive, and probably they assure you a default and they take your collateral. So in the paper, I just needed more clarity, just a few more reasons on why you think RCC and TC are not so different. And then also you indicated one of the challenges was COVID, that the first 2 rounds of the surveys were in person, right? And then the final round was COVID. Because of COVID, you had telephone calls to these households. I don't know how, there is no discussion at all on how the change in the survey instruments could have affected the results. Maybe that. So thank you. Those are my comments. Yeah.
All right, thank you. I think towards the end, I think I mentioned where we see the effect of RCC over TC, and for now it's on the uptake of credit. But I think at the moment, as we know, credit uptake amongst the farmers you're talking about, it's already very, very, very low. But I think now maybe presenting them with an option that makes it less risky to take credit, then increases the chances of them adopting or taking credit, which the moment they take, I don't think, and especially the way we set up this study, I don't think the moment they take, then we would expect much differences thereafter. These were agricultural credits, and they are vouchers, maybe a little bit more details, which are not in the presentation, but in the paper. They are vouchers you are giving them for inputs. So, and besides RCC being a little bit more expensive because of the premium component that they had to pay, besides that, the amount was the same. At least what they were offered was the same. Whether they took all of it or some of it or none, that was at their discretion. I think the moment they take that, the investment on farm will be pretty much the same. And there's another paper where we're looking at the impact of both of these on their productivity. And again, even there, we don't see much difference. I think then the major constraint here or limitation would be access to credit. So that's where, for now, I think we expect to see a huge difference between RCC and TC. The effects of COVID-19 on the data, I think you correctly say that. It's something we can discuss further. It's not in the presentation. I think it's a whole new discussion that I might start here. But yes, the second round of intervention, midway, that's when COVID hit, and travels were limited, and we couldn't go to the field. So we waited a bit and realized we wait forever. So we quickly decided to do phone calls. And one of the major effects, actually, it's on the index that we are using to compute resilience, because we had to really make the tool shorter. So during the face-to-face surveys, it was a bit more detailed, where we were even doing both the reliance on those coping mechanisms, but also the frequencies, which we were not able to do that with the phone survey. And we had to convert now across all the surveys. We had to convert the index to a binary, whether at least that coping mechanism was mentioned. I think that's a major one for this paper because it affects the index that we are using. And again, we could have easily gone to midline and analyzed this using midline. But again, the computation of indices needs at least one lag. And the moment we do one lag, we've lost the baseline. Then your data, the data for analysis, it's really affected the amount of data points that you have. And so we preferred to converting the index to starting with a binary, whether one of the indexes was mentioned, and then using that to compute the aggregate index. Thank you. Yep. So is it me to choose? Then I'll jump to
Thank you so much. Very good presentation. My question was on the scoring. So you have like this index where you mentioned moving things from 1 to 8 and 8 to 1. I could see that there's like different components across 1 to 8. One thing that wasn't clear to me is it cumulative? Because I see, for example, on this end where you had like a longer bar, if I remember, it seems to me like some sort of like, moderate coping mechanism or something. But I also see that within this scale, you have both food consumption, dietary diversity, and food consumption like indices, and they could be all severe within. So, for example, within dietary diversity, of course, it means something different, moving from 10 different food options to one food option versus moving from 3 to 1. And the same for like food consumption, moving your proportions from, I don't know, a full plate of food to just like a quarter of a plate. So I wasn't really clear like on this one, how exactly it works. Then my second question is on the experiment. So again, this is sort of like an experiment in which you're measuring effects of credit on food security. So is it that the intervention was rolled out in a period when there was like higher food insecurity? I wasn't very clear on the setting of the experiment itself.
Thank you, Mike. Really interesting work. I was surprised that the risk contingent credit doesn't have a stronger effect than just credit alone. And you're saying that this is because sort of the treatment effects on food security or in resilience are the same, but the difference lies in take-up. But then I'm wondering why in your ITT you don't see stronger effects of risk contingent credit, because assuming that the treatment effect on the treated would be the same and that take-up is higher, we would want to see in the ITTs stronger effects than of the risk contingent credit product compared to traditional credit. So then I'm wondering, is there something in terms of treatment heterogeneity that because of the increased take-up in your risk contingent credit arm, that you get farmers who might be by nature less resilient and for whom you see lower treatment effects on the treated potentially, and that is why you don't see a stronger ITT? Or if farmers, because they have insured loans, if they take more risks, but you're saying that you don't see much in technology adoption, but perhaps there's something in risk-taking at the intensive margin that is not observable. But I think this is a really interesting mechanism to think more through, like what's happening in terms of the selection or the effects of your risk contingent credit arm, that your ITT isn't larger despite the greater adoption that you have of the credit product in that treatment arm.
Okay. All right, I think I'll start with your question, Barbara. So that's in a different paper. I think what we observe at the first paper, we see higher uptake, slightly higher uptake of RCC than traditional credit. And the one that looks at the impact on other outcomes, we see generally those who took credit, both RCC and TC, so they increased the use of improved seed and also fertilizer on their farms. But beyond that, we don't see much effect. And I get your question, then why? Because now that goes all the way to this. Now the differences between the two, again, that we do not observe. So, and as I said, quick thinking, but I think it's something we need to keep checking, especially as a mechanism towards that. So I think the moment they do take credit, and also the nature of credit that we were offering, and my own thinking, I don't also think now we expect much differences after that, because the moment they took, and also it's also good to mention that the uptake of also traditional credit was quite high. The difference was significant, but not much. Because these are farmers who generally do not have access to credit. And now here you've come as a program and you've offered them access to credit. So as much as we see some difference in uptake, it's not as big as we had hoped initially. So, but the nature of the intervention or the credit that we are giving them, the moment they get it, I think in terms of investment, the decisions thereafter would be pretty much similar. And that would mean the effect that credit would have on other outcomes like the one we are looking at here would pretty much be the same. But I agree, it's something that we can check further. So the reversal of the index from 1 to 8 and 8 to 1. So if you look at this, so if a household then selects just one of these, that means they are food secure. The more they select, the more food insecure they are. But again, now for the sake of the interpretation of these results, we reverse that such that as you move from 1 to 8, that means that household is becoming food secure rather than in the original form. So generally, what you could have seen if we didn't do that are negative coefficients. So, and here discussing resilience and all that, it's easier to have a positive indicator rather than a negative indicator. And for the experiment settings, the intervention was just before the onset of the rains, the season, which included, of course, randomly selected farmers being invited for trainings. And then after trainings, particularly on credit management and also being trained on the interventions that we were offering. Then after that, then they were given vouchers based on the treatment group that you are in. They are given vouchers, which now they could use to redeem input in specific agro dealers or in specific retailers. So and I think that you're asking whether it was during a high period of food insecurity. As I say, it's at the beginning of the season, and then we do collect data much later. I think one of the weakness, and again, it's because of COVID disruption, is that the last round of data collection was not around the same time as the other surveys. Because when you're doing especially measurement of food security and all that, you would want to go back around the same time throughout all the panels. But the last one, I think, was delayed with a few months. Yeah, but generally it's guided. The intervention is guided by the beginning or the start of the season, just before the rains. Thank you.
Thank you. So our paper simply looks at the payment system structure in Uganda. And I co-authored this with Mr. Jemiapa and Lorenzo from Bocconi University. We will be focusing on what specific frictions prevent development of the payment industry, first of all. And then also focus on how these frictions are likely to affect the credit market. Now, let's assume, I'm going to first describe for you the setup of the payment system structure in Uganda, right? Let's assume you would like to buy a cup of coffee. How would you pay for it? You can have three options. The first one is you could use cash. That means you have to move with a bag of cash every time you want to buy coffee. I've tried it here and my cash has been rejected. They told me, you need to use a card. In Uganda, probably if you have a card, you would be rejected. Now, the other option would be you go and probably walk to the bank and then write a form and tell your bank, please pay for my cup of coffee, and then you walk back to the restaurant and then you get your cup of coffee. The third option is what we call mobile money. It's an innovation. So Uganda is largely informal in nature. That means almost 80% of the people are not in formal activities. Every single person owns a phone number, but most of them don't have a bank account for very few reasons. It's difficult to open a bank account. Even if we were right here in the UK, you would have to fill in forms, declare, are you politically affiliated? Do you have connections to anyone? And then probably you don't know how to read and write in Uganda, okay? So mobile money companies, telecom companies, came up with a very novel idea and they said, look, all you need is your national ID, your identification card, or your social security number, the equivalent. You walk to someone and tell them, register me. And then on that ID, they can deposit money. Your cash can be tagged to that phone number. So it's quite easy. You can access mobile money quickly. You can register even when I want today, I can go back home and I get an account. Same day within 5 minutes, which is not the normal case in the banking setup. Now, this innovation actually picked up so fast, almost the entire country is now on mobile money. I come from the banking sector, from the civil service, and for the longest time, we have always wanted to see people in the tax brackets, but people had been hiding their money under cash, and we couldn't trace them. We didn't know where these people were, right? And then all of a sudden, everyone, because they have seen mobile money is easy, they have decided to join, and now we can see how much money they have. But we can't trace what activities they are doing with this money, but we know they are rich. It's just that we don't know how to tax them. So the government sat, we sat, I belong with the government. So we sat and decided, look, how do you collect money from these people? You don't know the activities they're generating this money from, okay? And then we just put a 1% tax on just mobile money. We didn't put it anywhere else. We just put it on these guys because the contribution of mobile money had become quite huge. Now, if you put the tax on one payment option, what happens to the others? Do people actually start to move and use a lot of cash to make their payments? That's a question that just comes up naturally. You could as well say, do people just stop picking deposits from their commercial banks or something like that? Now, it's a destabilizing tax, and it was quite unpopular. People rioted, people like their money. Now we were taking it as a value tax. Now, banks were observing all our moves. They had, first of all, created a financial innovation before we put our tax, right? And the thing was underperforming. No person would be onboarding on this financial innovation by the bank. But once we put the tax, what we see is that users started adopting the financial innovation of the bank, which essentially was replacing the use of mobile money. And with this financial innovation, you could easily access money and put it in your bank or use it to pay for you. It was quite inconveniencing, but it reduced the burden. And also what banks did is they spread out more automated teller machines across the country. Now, where does substitution occur? Does it occur at the mobile money level, at the cash level, or at the bank, or at the ATM level? You may wonder why we ask this question, and like I told you, there are quite a number of payment options. So if you look at the first, blue line, okay, this is mobile money before we put the tax. We were trading at about 140 million, peaking at this per month. The number of the value of transactions being paid for using mobile money, right? And this is what the innovation by banks was collecting. This is very minimal compared to this, right? And then once we put the tax, you're going to see that immediately, instantly, mobile money collapses. However, who is the winner? The commercial banks. People now start using more banking products compared to mobile money. And then we are going to assess this particular tax. We have a quite unique data set. In 2018, you can see that there were about 2 billion transactions through the mobile money system. And these were done by about 20 million users. But of this, we are going to focus on only 2 million geolocated individuals within the months in which the tax was imposed. Oh, sorry. And then we are going to complement this with another data set that tracks the development of the financial innovations by the bank. And then also we will see how the credit markets were also affected by the new liquidity in the financial system. So for identification, we are going to look at the, to assess, actually our entire paper came from this particular idea. It's a quite famous paper. It was the first to assess the effect of taxation on the use of mobile money. And I'm glad the author is in this room. And we are going to complement this particular identification strategy with geographical variation that shows the presence of automated teller machines at every administrative level within Uganda. And then here we'll be able to look at the administrative level effects. I'm trying to avoid using the word district because here it could mean something else. In Uganda, I think it's level 3 administrative region. And then also we will have fixed effects to do with where these ATMs are high, are more than in other districts. Now, back to the identification strategy. This graph is adopted from the first paper that assessed the taxation of mobile money. Now, if you look closely, this is the date on which we imposed the tax. This one, okay? Right before we put the tax, you can clearly see that no single Ugandan had interest in taxation. Everyone was going about their life doing. I mean, you pick your phone, you open it up, you're going to search about something else, okay? And then all of a sudden, you wake up and your money is being taxed and it's disappearing. This is the spike in interest. So we are going to argue that whatever regulations we are going to do are based on a purely unanticipated tax. And you see, once people realize this was it, then you see the interest also fizzling out because later on a few changes came up. Now we are going to use the basic 2 equations, the diff in diff and the event study. If you look at the first equation, our comparison area is going to be on districts that have high ATM density. We are going to create, it's like a dummy. So you will split our data into districts that have quite a number of ATMs, and then those will be the ones we'll be comparing to versus those that don't have. And then also we'll track the few periods before the tax and the few periods after the tax. And then we will have the following fixed effects. We will have districts and then bank fixed effects. And what we observe the immediate outcome is going to be a collapse in mobile money in both regressions. And it collapses for whatever reason you use the platform. This is a platform you can use to send money. You can see right here. So this is before and this is after, okay? So the number of the people sending money through the platform collapse. The reasons include, for example, the posting. You could just walk to the agent and post money. Also, those people stop going there, okay? And this also, it's important to note that we are comparing between high ATM regions versus low ATM regions. It means that where there is no alternative options, those are the people who suffer the most. Now, when you look at adoption of bank-related technology, it goes up. The moment you put a tax on one payment option, expect the alternative to benefit. Okay? Sorry. You can see that the innovation which we call banking agents, before we put the policy, districts that had more ATMs versus fewer ATMs, they are more or less the same. Everything was flat. And actually, it was literally running out of business. But after the tax, you see that districts that have a high substitutability option also ended up adopting more technological advances by the banks. It means that a person could actually just walk to the agent, give them their money, and this agent deposited through the ATM. In the high ATM districts, you can see that pre-policy, there were just 2 agents on average. But after the policy, you have the number of agents rising to about 120. And then also, if you look at the amount of money flowing, districts that had more substitutability options, that means the ATMs, they received more deposits relative to the other districts. And this graph shows you the time lapse of the adoption of the technology. So it's just to reset it a little. You can see that in the first month, the technology was nowhere. But by the end of around the first year, almost the entire country, each area you see there that has a boundary is the administrative area. I was talking about that district. By the end of 2021, I mean, every single person in the country almost was on the financial innovation. Now, also it's important for us to ask what happens to cash? Because we've been talking about the fact that mobile money is collapsing, but what's happening on the side of cash, people moving around with cash? So we have this quite unique data set again that captures the amount of cash that is being withdrawn through the ATM system. And you can see that wherever there were more ATMs, you expect the use of cash to go up because these people have an option. They can, you don't have to be locked in the financial system of mobile money. You could just choose to adopt another one because you have an alternative, okay? Compared to where there were no ATM options. Where there were no ATM options, I mean, you're locked in forever. And then what we've seen so far is that once you have a shock on mobile money or the entire financial system, you expect a drop in mobile money usage. And of course, you will observe that there is an adoption of alternative technologies. And then also, you know that once banks innovate, they are going to have higher inflows, right? And then finally, we know that we have to know that once they get this money, what do they do with it? How would it affect the credit market? Well, the interest of time, I'm rushing through this, is you will see that pre the policy, banks probably were liquidity constrained, but with the arrival of more money that has been diverted from the escrow accounts of mobile money companies, and now is on the actual operating accounts of banks, you see that they have issued more credit. And this is more especially to the districts that have high ATM density, because that's where liquidity is more likely to be realized. So overall, what we learned so far is that digital payment systems that are not owned by banks, in most cases, will crowd out the banking sector. And then also, if you have a monopoly on these technologies, then you're going to prevent financial innovation. And then following the shocks, we have seen that banks face volatility in liquidity, and then they will just end up issuing quite significant amounts of credit, and they transfer the range from high to low risk borrowers. Thank you all.
Yeah, I'm a LaTeX guy, as you can tell. Okay, thank you, Samuel. I think this was a great presentation. I'm gonna start. It's gonna be a quick discussion, really 5 minutes, as recommended. I'm gonna start with a very, very simple summary of your take-home messages, and then move to my general and more detailed comments. So what you find essentially, in a nutshell, is that the tax had a twofold consequences. First, a surge in the more traditional banking activities, and second, an increase in liquidity within the banking sector, essentially. And this generated a pronounced reduction in the usage of mobile money, as you clearly showed already from the descriptive statistics. This was very clear in favor of other means of payment, such as cash, and also money storage, such as bank deposits. And what I think was the really most interesting finding at the end of the papers was the fact that as a consequence of this, banks increased lending to low-risk customers and reduced lending to high-risk ones. So my comments are divided into an overall assessment and then comments and suggestions on the empirics. I must do a premise, and the premise is that I am completely unfamiliar with this literature. So most of my comments are going to be on the empiric side, basically because I'm also a very applied guy, as you understood from my presentation. So my overall assessment of the paper is that the paper is interesting and very well written. I must say that it was really an easy read, especially for someone like me outside of this literature. So I enjoyed reading the paper. It was not difficult to digest. And then the data are amazing. I think everyone in the room got this. The data, I was really impressed by the richness of the data that you use in this paper. Amazing, especially considering also the context from which the data originate. Really, really impressive. The research questions are clearly very policy relevant, and also evidence from such a context I think is particularly policy relevant compared to what's available in the literature, as I learned from the literature review in your paper, which is mostly concentrated on other settings, and this adds, I think, valuable and much needed evidence. And then the contribution, even for someone like me that is not familiar with the literature, it is clear that there is a strong contribution in this paper because it's really well framed also within your review of the literature. So I could really understand what's the value added of this work. This is the overall assessment. So really, congratulations. It's really a very, very interesting and well done work. My comments on the empiric side, as I said. The very first thing that I noticed when I started to think about your paper and I was reading about your identification strategy is that you don't really have a control group. Meaning that I'm quite familiar with this setting because for completely different reasons, I have worked a lot on how to make causal inference in the absence of a control group in the last few years. And the very first thing I noticed is that you lack a clear control group because this was a universal shock. This was a universal policy change that affected the whole of Uganda, meaning that you don't have clean control areas. So what do you do to recover some variation? There is no cross-sectional variation in exposure to the original treatment, which is the tax that affected all of Uganda. So how do you recover some variation? Essentially, you interact your treatment dummy, which essentially takes value 0 for all areas before July 2018 and value 1 for all areas after July 2018. You interact this dummy with essentially the density of the ATM at the local level. No? And in this way, you recover variation. This comes at a cost, however, that I think is very important to emphasize, the fact that you don't have a clean control group, you're essentially comparing less treated versus more treated areas. I think you might want to think more critically about that, not about, I'm not talking so much about the actual evidence, because I think it's also clearly from the descriptive that something is going on, but mostly about identification, meaning the causal assumptions you need to clearly identify the effects, and also the causal estimate that you are estimating in this way. I strongly suggest that you look at this paper by Xu et al. This is a working paper published in 2024 by top political scientists, which is called Factorial Difference in Differences. Essentially, it's exactly about that. How to really interpret. It's about identification in a difference in different setting in which people just like you interact a universal treatment with the baseline factor to recover some variation in the exposure to the treatment. You will see that there are unstated assumptions. This is not analogous to a basic difference in difference design. There are additional assumptions that you are doing, including an additional unstated parallel trends assumption. I think you might want to check for that, because it's also important for the interpretation of your results, because I don't think you are really estimating the average treatment effects, but something which is of course strongly related, but the interpretation is more subtle. Related to this, I was also thinking about potential suit violations of the stable unit treatment value assumption, not so much regarding the no interference assumption, but rather regarding the first part of suit, which is that there should be no hidden versions of the treatment, this setting, less treated versus more treated. I think this might also be problematic from that viewpoint. You might want at least to elaborate about this in the paper. And given these issues regarding the lack of a clean control group, I would have really liked to see, and I would like to see a placebo test in which essentially you show me that if you randomly reshuffle the density of ATM across Uganda, or you use as a fake treatment group the areas with low minimal / null coverage of ATM, and you don't find any effect whatsoever. I think this would greatly strengthen the credibility of your research design. And then careful with the functional forms transformations in the difference in differences design, because you take logs, then you exclude the zeros, you do a bit of transformations, but I strongly recommend to quote and discuss and also show robustness to what has been shown in this paper by Roth and Santana published in Econometrica 2023, in which essentially they show that difference in difference design is, and in particular the parallel trends assumption, and you have two parallel trends assumptions here. One is the one you state in the paper, the other is related to the paper I was talking about, is very sensitive to functional forms transformations, and you do such transformations. So we might also perhaps discuss these, show robustness with this if you don't take logs or don't apply these transformations. I think it's very important. Last thing is a curiosity. I am not sure. So the banking agent results that you also showed in the presentations is the first time that I see pre-treatment estimates that are not only close to zero, but they look like exactly the same, identical point estimates. I'm not sure what is going on there. It's very curious results, and it appears in multiple results in the paper, not just in the table that you showed. You might want to check whether it's okay, or anyway, comment on that. Okay, that's it.
Thanks, Marco. Those are very great comments. And I think most of them were known questions. So I'm going to try to take them into account, right? I don't try to address most of them. Maybe I will just look at a few things. The placebo test. I mean, if you look at us conducting it, we would have to first consider the first comments you gave, right? Sorry? Regarding the test, of maybe if we wanted to test, if we abandon the high ATM densities and then we refocus on other districts, probably we reduce the thresholds and then we would see what would happen there. That's something I think we could still consider. Lack of a clean control group. This is a tough one. Every single presentation I've made so far, it's the first comment that comes up. And I think you're the first to raise it out extremely well. So we will try to refine it, given that you've given us a paper to refer to. So thank you for that. Any other questions?
I mean, I see your struggles, but I think you'll be fine. One question that I seem to have is, given that like the intervention itself is introduction of tax, then I ask myself whether these changes are in response to the tax itself, or whether people are just like cost sensitive. Because I mean, it could just be that people don't want to pay tax whatsoever. So whether it is a cheaper alternative than another option, they're just not going to pay tax. But it could be that they are also just cost sensitive and they're trying to respond to cheaper options. And the reason I ask this is, maybe you could also check like where this a lot of the movement is. Is it 1% of 100 shillings? Ugandan shillings is just one shilling, but it might be that then making a withdrawal in the ATM costs you 30 shillings, which is 30% of the cost. So one way might be like to check where a lot of the movement is. Is it like on lower value transactions or higher value transactions, so that you know whether people are actually mostly responding to cost or mostly responding to the tax itself?
Yeah.
Yeah, thank you. Great talk. It was interesting to see the divergence between the sort of low and high coverage, ATM coverage regions, like sort of fade out over time, or it seemed like the difference was smaller 5 months after the tax. Do you, like, it would be very interesting to know, have you looked at data, or is there data even available more than 5 months afterwards to see whether this was like a one-time thing or not?
Yeah, you're referring to...
maybe a few slides back? I'm not sure. That one, yeah.
Okay.
Thanks.
So, other questions? Okay. So, back to your question of are people reacting to something else? Now, the founding idea here is, first we want to say is that everything is unanticipated, okay? But beyond that, you would expect that there is something probably behavioral in nature. That's what you're raising, but it could be that, I mean, people just hate the government. It could be that. And they believe that if they lose their money, or they give you their money, you're not going to build a road, you're not going to do something, so probably they're not going to pay it. So it's a nice comment, and I think we are going to investigate that further. However, we have already started again. We have an extension of this paper that tries to separate those particular effects to see if, I mean, it could be that people basically just, anything to do with government, people will react differently. Okay, so I guess we'll share with you the extended analysis. And then regarding why this dies out is along the way, this is July, along the way you expect that people start to cope. So it's more to do with a coping mechanism. You accept your fate and it gets sealed and you choose to pay. But later on also, government started communicating that they were going to repeal this particular policy. And indeed, in November, they repealed the policy and left it at 50%. Yes?
Yeah, I was going to say they removed the tax on sending, receiving, and depositing and left it on withdrawals, but half the rate. So around the 5th month there's actually a change in the way that the policy was working.
Yeah, I mean, it goes all the way to zero, so yeah. So I think, any other questions? I think we are good to go.